1.
All right, we're going to be talking about quadratic formula today. This should be all review. The only thing that's different in Algebra 2 with quadratic formula is that we may have a negative underneath the square root. That's the only difference as far as what kind of answers you're going to get. We've been dealing with complex answers for the last week, so it shouldn't be that big a deal. Inside the quadratic formula, you know, we're dealing with a quadratic equation in standard form. And you remember the quadratic formula? All of those A, B's, and C's are just the coefficients of the right pieces of quadratic. To do quadratic formula, yes, ma'am. Good. You want to sing it for us? Come up here so it'll record it.
I got you.
All right, you're close enough. You can say it, it'll still get you.
X equals negative b plus or minus radical b squared minus 4ac divided by 2a.
Good job. All right. So now, one of the keys to quadratic formula is it's a lot like factoring. It's got to be equal to 0 first. So this is different than if we're trying to solve by square roots. We didn't get it equal to 0 to solve by square roots or to complete the square. So we've got to have it equal to 0 first, and then we can employ this quadratic formula. The great thing about quadratic formula is it works every time as long as we don't mess up the arithmetic that's involved there, okay? Complete the square works every time. Factoring doesn't work every time. So this will even give us answers on the problems that won't factor or the problems that will factor, okay? So inside of that quadratic formula, there's this very important piece right there. That's called the discriminant. The discriminant, root word for that is discriminate. Discriminant, it discriminates what kind of answers you're going to have based on what that number is that's underneath the square root. If that number, if b squared minus 4ac is greater than 0, then we're going to have real solutions. If that is a negative number or less than 0, we're going to have complex. Okay, and we'll relate this a little bit when we get into the graphing part next. Starting on Wednesday, we'll get into graphing from quadratics, and we're going to relate all the solving that we've done. It's going to relate back to parts of our graph that we need, and knowing that discriminant is going to help us know whether we need to put a certain thing on our graph out of that. So being able to do that's kind of very important, actually. So real solutions, complex solutions. If it's equal to 0, because this doesn't take care of that. If b squared minus 4ac is equal to 0, then we have one real solution. Okay, one real solution. Any other case, we got two answers always, because it's quadratic. We should get two answers anyway. We've seen that the entire time we've been solving quadratics. Okay, so let's just take a few examples and get some practice doing some quadratic formula on an equation or two. I won't spend a ton of time on this. You know, got a quadratic. It's equal to 0 already, so I can use the quadratic formula to solve it. That's what I want to do. Okay, so I want to find the discriminant first, and I think it's intuitive to do that first because it's going to simplify the whole formula. Sometimes, a lot of times, if we got a lot going on, and you look at that quadratic formula, you know, there's a lot going on in there. There's a b squared minus 4ac. There's a lot of operation happening inside of that square root. So if we'll do the discriminant separate, then all we got to do is put that answer underneath the square root. It makes it a lot simpler to do. So let's do that discriminant. What's b on this problem? 3. So we got 3 squared minus 4. What's a? 1, and c? Negative 2. Yeah, that minus in front makes it a negative 2. And that's going to get us our discriminant if we just work that out. So that'd be 9 plus 8 is 17. Okay, so whether you type that in the calculator or whatever you want to do there to get that number. What kind of answers are we going to have?
Real.
Real. Why?
17 is greater than 0.
Yeah, 17 is a positive number. So we know we're going to have real solutions. What we're going to see later on this week is what that means that thing is going to cross the x-axis. That's all that means. Okay, Kylie? The 1 came from right here in front of the x squared. That's A. Remember your discriminant. Your discriminant is b squared minus 4ac. So b, 4 is always there, then A and C.
So every problem we go off of that top problem.
Yes, absolutely. Today, that is exactly what you want to do. No doubt.
And then
All
we just plug it in.
Plug it in. That is really all you do. So let's plug in the rest of it and simplify it. We got to simplify it once we plug it in, though. So negative b, so that'd be negative 3 plus or minus the square root of 17 over 2 times 1. And I'm just going to simplify as much as I can. Negative 3 doesn't simplify, doesn't do anything. The square root of 17, that's a prime number. So I know that radical is not going to simplify like we did last week. So it's just going to be radical 17. And then 2 times 1 is 2. So I have two solutions here. I have negative 3 plus the square root of 17 over 2. And then I have negative 3 minus the square root of 17 over 2. If I wanted a decimal approximation for that, these are the exact answers. There are times you want a decimal approximation. When we get to graphing later on this week, we're going to want decimal approximations for that. So let's get those decimal approximations for that, just to get the practice doing it. And it's not just entirely difficult to do. So let me get to the regular calculator screen. And I just want to type in negative 3 plus the square root of 17 divided by 2. I did the plus and I get positive 0.56 if we go 2 decimal places.
It's different if you don't then divide by 2.
If you don't type it in correct, if you typed it in without parentheses, then you're going to have a problem. Like you would need to put that part in parentheses. If you want to type it all in as one problem, you need to put that numerator in parentheses like this. Negative 3 minus square root of 17. Get outside of that. Parentheses divided by 2. And then negative 3.56. Ain't good. So those are our two solutions. The exact solution is going to have the radical left in it. The decimal approximation there, go 2 decimal places. That's all I'm asking for. Okay. So there's one with the real solutions. Not a whole lot to that. Let's go to this one.
You said go to new decimal place.
Yeah, round your decimal approximations to 2 decimal places. So look at the third number. If it's a 5 or higher, go up.
I thought you meant like move the decimal.
No, don't move. No, don't do that at all. That would be percentages.
That's what I was
All right. So here we have x squared is equal to 6x minus 4. What do we need to do to that first? We make it equal to 0. And now with quadratic formula, it doesn't matter which direction you go. When we were factoring, we wanted to get the x squared positive. So we wouldn't have moved the x squared, we'd move 6x and 4. That's what I'm going to do here anyway, because I don't want to add any extra negatives to my problem that I have to. But you could move the x squared and have negative x squared plus 6x minus 4 if you wanted to. I'm just going to do, just a quick minus 6x plus 4. And so that'd be x squared minus 6x plus 4. No matter which direction you move everything, as long as you got it equal to 0 and in descending order, once you work out your quadratic formula, it's going to get you the exact same 2 answers. You may have to do a little bit more simplifying with the negative signs in there if you move the x squared, which is why I don't usually have an x squared if I can help it. Okay. All right, so let's get to discriminant. And I'll just abbreviate that disc. There's nothing else we use that has that connotation. So what's the discriminant of this one? Negative 6 squared times 4 times 1 times 4. So it'd be 36 minus 16, which is 20. So what kind of solutions are we going to have? Real or real or complex? Real, because what kind of number is it? Positive. Positive number on the discriminant gives us real solutions. Okay, so that's something we need to know. That's going to help us throughout everything we do from here on out. All right, so then just plug it in. So 6 plus or minus square root of 20 over 2 times 1. Yes, absolutely. Jordan, go ahead.
How do you know what to fill into that problem? Like, where things go?
I know because the formula is always negative b plus or minus, then the square root of the discriminant.
Okay, so b is the discriminant.
B squared minus 4ac. This stuff is the discriminant. Whatever's under the radical, that's the discriminant. That's where that's coming from. B is always the number in front of x. A is always the number in front of x squared. Okay? And then C is always the plain number that's there. Okay? The formula has negative b, so this was a minus 6. We changed it to a plus out of that. If you want to see the proof of that, we can do it. Yeah, double negative. Just change the sign of it. It's really all you got to remember there. And then, yes, McKenna said, are you going to break down that 20? Yes, we are, because it's under a square root. What does the square root of 20 reduce to be? 2 radical 5. Yeah, 2 radical 5. And then 2 times 1 is 2. This is where when we write our exact solutions, we can simplify a little bit. Because I can split it apart like this. And it simplifies a little bit to get us 3 plus or minus radical 5. And then I want to write my exact solutions and my decimal approximations for that. If it's real solutions, that's when I want you to get decimal approximations. If it's real solutions. If we're going to do one with the complex in just a minute. We don't need decimal approximations for those because they're not going to cross the x-axis, so we don't need to know where that number is at. We do need to know where 3 plus radical 5 is. So calculator time. I don't know my square root of 5. I have it memorized. Plus square root of 5. There's no division on this one because I simplified it already. So 5.24. And then I need to do 3 minus square root of 5. Well, look at the third number. If it's a 5 or higher, we go up. If it's a 1 through 4 or 0 through 4, you stay the same.
But only on the third.
Only on the third number. If we're rounding to 2 decimal places, you always look to the next one and go by it. So I want 2 decimal places the whole time today.
I guess that's where I'm saying.
Okay.
I mean decimal places.
We're going 2 the whole day. Unless you get to a problem that's asks you to do 3.
On these answers, you get answers.
So that would be 764.
It'd be 0.76.
And then the top one would be
5.224, yes.
Oh my God.
So I was making sure because I didn't know if it was change to 6 or you wanted to change to 3.
I want you to look at the third one to change the second one.
I got a pen.
There we go.
Hey, you can have this. Somebody
Oh yeah,
donated
that is mine.
it. Well, you donated it then.
Miss Ambrose's. He thought garbage.
Is it not right? I'll get it later.
We need to write that through.
I want to see that from you today. Is the exact answer and then what's its decimal? The exact answer and what's its decimal?
Oh, I got you.
What's its decimal there? Okay. All right, let's go to Example C. Let's say we got negative x squared plus 4x equals 5. Okay.
I don't even know how to write these problems. I never gotten this. My paper was open.
Well,
Don't know what to tell you.
how I write them on the screen is how you want to write them, I guess. So,
I know.
I don't know if
It's like all
that's a good
stuff.
explanation, but that. All right, so we want to get it equal to what? 0. So you got two options.
-5.
-5 is the quickest way to get it equal to 0, but you got to deal with the negatives. But that's okay. We'll make it work dealing with that. That's fine. I don't care either way. You just got to watch your signs a little. So it'd be x. Yeah, A would be -1. B would be 4. And C is now -5. So let's get the discriminant. 4 squared minus 4 times -1 times -5. This will be 16 minus 20, which is -4. So that means we have what kind of answers?
Complex.
Two complex solutions. Complex solutions, because it's a negative number. That also means when we get to graphing later this week, I'm trying to tie it together starting now, that this is not going to cross the x-axis because it's complex solutions. Complex solutions don't cross the x-axis. Real solutions do. So that also tells us we don't have to get decimal approximations. Okay? That makes sense? We don't need decimal approximations if it's complex answers.
Only on
the real answers. So because that's a negative, that tells us it's going to be complex. Okay. You just need to tie that together. All right, and then just go to your formula, negative b. So instead of 4, it's going to be -4 plus or minus the square root of -4. And remember this -4 under the square root's the discriminant over 2 times -1. So then we're going to simplify. What's the square root of -4? 2i. Good job. And then 2 times -1 is -2 on the bottom. So we're going to split that, simplify that by splitting it into two fractions with the -2 on the bottom.
Yeah, can you not simplify the forward and then just be I and then -2?
That's what I'm doing. I think I'm doing what you're saying
Like I wrote
to
it
do.
down, and mine's a 4, a -4, and 4, -4. So yeah,
I put a little.
the.
So that would be 2 plus or minus I. No.
I would just keep
Because it doesn't really, the plus or minus takes care of it either way there. So there's really no such thing as negative I on this part of the world. Okay, so you've got two solutions. One is 2 plus I, the other one is 2 minus I. We're not getting decimal approximations for the complex solution, so we can stop right there and say that's our answers.
if our calculator puts it in as 2 minus I, and we write 2 minus I.
What do you mean?
Like, whenever I went to that problem and I was using my calculator, it put 2 minus I as my answer.
How did it do that? Show me how it did it. Oh, okay. You plug in that and it gave you 2 minus I, which you just got to remember you got the plus side as
Yeah,
well.
plus. You can tell me
Yeah.
if it's
All right. Good questions. We're moving in the right direction. Let's do another.
So this one will have 2 answers.
Well, it does have 2 answers. One answer is the plus and the minus. We're not going to get decimals because it's complex. Complex, we don't need decimals for because we're not looking for a spot on the graph is what we're after. All right, so let's look at this one.
My calculator spells like that. No, I'm just kidding. That's it, my calculator.
So let me call your mom.
No, Oh, she's like a big young butt.
All right, guys. So we got a little bit more complicated looking problem to start off with. But what do we just have to remember to do?
Put it where it's equal.
Get it equal to 0. That's all you got to know. And then get it in order, descending order. X squared first, then plain X, and then numbers. Okay? So,
Think about it.
yes, that's what you want to do. So I'm going to subtract 2x from the 7x. And then a 3 from the -4. And then I'm going to go -5x squared plus 5x minus 7.
No, well, I'm not good at adding.
How is it now
At
5?
all.
Plus, how's it plus now?
Because that's a +7 minus 2. And I rearranged order. The
Oh.
-5x squared comes to the front. Because you want it A, B, C.
Now I get it.
Order out of that.
It still messes me up.
Yeah, me too.
Just got to be careful on your signs. And if you've got to write an extra step, do it. I mean, I skip a few steps here and there in Algebra 2 that I don't skip in Algebra 1. If y'all had me for Algebra 1, I wrote every step down.
Yeah,
And you know that. So
about 4
in Algebra 2, I don't do that. Just because yeah. Well, you could, I don't know if it'd be that much, but all right. So now we got A, B, and C. So we're ready to do the discriminant of that. So B squared minus 4AC, just got to plug in the stuff we know. So that's 5 squared minus 4 times -5 times -7. So, define funky number.
Like -3, 35,000.
I think something wrong.
I put something in there wrong. I don't know.
All right, so I'm doing 5 squared.
I didn't put it negative, that's fine.
That would make all the difference in the world.
No.
Not -4, but -5. -7.
You're trying.
-115.
Yep.
The dream.
I get lost. Oh, yeah, I didn't get that.
What?
What did you get that?
Kiana got that.
Huh?
You got that right? Didn't you say yeah when I said 181?
Well, I don't have my calculator, so I'm doing it.
Oh no, that's not good. You gotta have that thing.
Since we're trying to do it in your head.
All right, now, so I know that's going to be underneath my radical. So I have what kind of answers? Complex. Okay, so negative number as a discriminant. I know I've got complex answers. So then I'm going to go to my quadratic formula. Negative b would be -5 plus or minus the square root of -115 over 2 times -5. And this -5 here is the a in front of x squared. Is
So
it?
we don't have to put it in the problems this time.
No, because it's complex. If it's real solutions, yes. If it's complex solutions, no.
So when we put it in the calculator with like the top part, we put plus or minus.
One or the other.
Don't matter.
If you're going to ask it to simplify this one won't work real well like that because square root of 115 is not like the 4 was earlier. So it's not going to give you back that I thing. It'll give you an I and then a big ugly decimal, which is bad. So this is where we're doing it by hand is kind of what we want to do here. So we want to break down the 115 and see if it will simplify because I know the I comes out and then I got a -10 on the bottom. So 115, a 5 goes into it 23 times, which I can stop right there. 23 is prime, so I don't have to do anything else. I know the 115 is not going to break down. But I do know that I could kind of split this apart and get it into that complex form that we dealt with when we were doing the complex number section, where we wrote it as -5 over -10 plus or minus I radical 115 over -10. And part of that will simplify is the reason I want to do that. That front part there, that's 1/2 plus or minus I radical 115. And then the negative goes away on the 10. Because If I divide positive radical 115 by negative 10, I get a negative answer. That's the minus part. If I divide negative radical 115 by negative 10, that's the positive part. So the plus or minus takes care of that sign on the second half. So this is in complex form. Is the reason I wrote it like that, because that's the standard way of writing a complex number, like that. That's how I would expect to see your answers. I would hope, anyway. All right. I got one more, guys. Can you handle one more?
So that's our answer?
That's your answer.
Oh, yeah. I'm trying, but it's just in here, it ain't getting no smoke.
One more example. One more example. Y'all can make it through that. We're done.
We're done.
For the day, yeah.
Yep.
And another than you doing work, doing some practice. Well, in 58 minutes, the day will be over. Okay. All right. So we got 4x squared minus 10x, and that's equal to 2x minus 9. So again, what do we got to get it equal to? 0. So that's all we're doing to start off with. Guys have got that down pat. There's 0. And then the other side just got to simplify.
Do you have to
And then make sure you got it in order, x squared, x, and then a number. If the plain x in the middle is missing, it's just, then we just know b is 0. That's if one part of it is missing, it's a 0. Then you can still do quadratic formula with it. Just put a 0 in the place. All right. Discriminant. Negative 12 squared minus 4 times 4 times 9. Excuse me. So b is the negative 12, and then when I get to the quadratic formula, it's just going to change the sign of the b. But so that's 144 minus how much? Which would be a discriminant of 0. So that means how many answers are we going to have? 1. What kind?
1.
One real solution, because 0 is not a negative number, right? So that makes it real. So we have one real solution, and we just got to work that out. It's really, these are the easiest ones, because you just negative b plus or minus the square root of 0, and then 2 times 4 on the bottom. Well, what's the square root of 0? What's 12 plus 0? 12. What's 12 minus 0? 12. So we end up with 12 over 8, which is reducible, 3 over 2, and 0.5, right, as a decimal, if we think about that. So that's what x equals, 3 over 2, or 1.5. No approximation on that one, because it works out, terminates to 1.5, okay? Okay, quadratic formula. A very, very useful way of solving quadratics. All right, so what I want you to practice on the rest of the time, you got 55 minutes left in class, kids. You guys are kids. You're not old like me. I beg to differ. I don't know if I'm still grown yet. So
If you're still grown,
I don't know if I'm grown yet. That's what I meant. I am, so it's okay. All right, let me.
I feel old.